Okay, hello everyone. This is the introduction to oscilloscopes. An oscilloscope is a really valuable tool. It lets us do electrical troubleshooting and understanding what signals look like. The problem with electronics for us measuring things is that signals are usually very fast. Things happen in kilohertz, megahertz, gigahertz. That's impossible to see with the naked eye. When you measure something with a multimeter, you're getting a static value, some voltage that's not changing. But what do you do if you need to measure something that's changing and potentially changing really quickly? So that's what we use an oscilloscope for. It can be used to look at any kind of signal, digital, analog, as long as it's a voltage changing with time. You can measure serial communication ports. You can measure sensor values. We'll use them a lot. So it's a really valuable tool, and it's a really good thing to know how to use. So this is the oscilloscope. We'll walk through the basic components of it. There's a screen here that's displaying the signal that we're measuring. This is a 4-channel scope, which means we have 1, 2, 3, 4 channels that we can measure simultaneously. Each one of these wires goes to a scope probe, which looks like this. Okay, this is basically the end of a multimeter. It comes with this little clip that's pretty handy for hooking onto things, which we'll show. If you disconnect this, you can probe with that tip. And this is called the ground clip. So basically what you're doing is, this is the red side of the multimeter, this is the black side of the multimeter. You can clip this onto a ground reference on your circuit, and you can use this to probe different signals. So we're going to basically measure something called a calibration signal, which is something every scope has built into it. It lets you make sure that the scope is functioning. It lets you make sure that the scope probe is functioning, so you don't waste a lot of time troubleshooting a scope probe that's broken. And it's really easy to do this. So we're going to take this first channel scope probe, and we're going to connect it to this thing down here that says cal on it. Okay, cal stands for calibration. I'm going to take the ground clip and I'm going to connect it to the ground symbol here. And you see the display changed, but we can't really tell what's going on yet. So I'm going to do a couple things here to clean up this signal, and so we can see what it actually looks like. First, let me get rid of these cursors just for to clean up the screen. Okay, so we're looking at channel 1. There's nothing connected to channel 2. The important things to learn, there's a lot of buttons here, but you need to understand how to use the voltage and time adjustments, okay? There's 2 knobs per section. So voltage is the y-axis, and this is the scale. So how many volts per each one of these grid elements. And this bottom one is position. So if you need to move signals up and down so you can see multiple signals at the same time, it's really handy to be able to not have them all lay on top of each other. This one here is horizontal, so that's the time scale, how many seconds or milliseconds or microseconds, nanoseconds you want per division. And again, this bottom one lets you move the x-axis left and right to help you find what you're looking for. So the first thing we'll do, which probably will get us exactly where we need to go, is we'll hit this auto setup button. That will try and find a repeating signal. And there you go. We don't have to do anything other than that. It found the signal for us, and it put it in a nice, easy to see scale that shows us what's happening here. And so what's coming out of this port is a square wave, and we'll go and measure the properties of that square wave right now. But you can see this is it, the yellow line. If I change the scale, I can zoom in or out on the y-axis, okay? And if I move this knob, I can move this anywhere I want on the screen, okay? And that's just for convenience. Same thing with the x-axis. I can zoom in or out depending on what I'm trying to look at. And not as useful in this mode, but you can move this left and right if you're trying to search for something specific. Okay, so what is this square wave exactly? There's a couple different ways we can figure that out. The most basic way is to use these cursors. So this will let you put lines on the y-axis and the x-axis and measure the difference between the two. So here at the bottom, you'll see a bunch of menu options that come up. This middle button is the one that lets you select between X or Y, or if you want to move X and Y. But we'll start with X, and we're going to use this knob here. So let's click the button so that we select X. Now I can move one of these lines. We'll move it right there, and then I can click it again, and I think that selects both. I'll click it a third time. Now I can move just this one. Okay? So now, this is one full period of this square wave. If I look here, x1 is at basically 0 seconds. x2 is negative 1 millisecond. And it'll tell me the delta between the two, so negative 1 millisecond. That's just because I put this line on the left side of the 0 origin. I can move it to the other side, and it'll say plus 1 millisecond, right? And now the other cool thing is it will automatically calculate the frequency for you. So this is the period, 1 millisecond. Divide that 1 over that number is 1 kilohertz. So this is a 1 kilohertz square wave. Now another useful thing to look at would be the voltage. So if I click cursors to bring up this menu again, and I select Y this time, I'm going to do the same thing. Click that button, and I'm going to move this basically to the bottom of that signal, and I'll move the other line to the top, and I can see here I have delta Y is 3.24 volts. If I invert these and switch them around, I'll get positive, right? So basically it's a 3-volt signal at 1 kilohertz, okay? So that's the properties of this calibration square wave. Another way to figure this out, sometimes it works well, sometimes it doesn't. If it's a really periodic signal, it will work pretty well. You can press this math button, and that will okay, you can press this measure button, and we say channel 1 is the source, and now we tell it what type of measurement we want. There's a lot of options. So let's say we want to find the frequency. So I'm going to say, let's add frequency, and we already have period. And then the voltage from the top to the bottom we call peak to peak, and so we'll leave that one selected. You can also pick, minimum, maximum, a bunch of different options, which we won't really get into. And now if I press measure again, you can see over here it says you can see over here now it says peak to peak voltage 3.2 volts, so that's pretty close to what we had on our cursors. Period 1 millisecond, that matches. Frequency, 1 kilohertz. It's saying it's 999.9 hertz, but that's basically a kilohertz. So all this matches what we calculated with the cursors, which is good. Like I said, sometimes this will work really well for a repeating signal. Other times it could be hit or miss. So the cursors are the backup way to get that information.